Hi everyone, welcome to the DREDGEPACK Software webinar. My name is Brittany Hines, Marketing Specialist here at HiPAC, and I will be your host for today's presentation. Before we begin, I just want to remind you about the question box on the side of your screen. We will be taking questions at the end of the webinar, so please submit them there using the question dropdown. Also, if you are unable to hear us or the screen goes blank, please comment in the chat box so we can fix the issue. For today's webinar, we are going to show you some of the new features in our DREDGEPACK software. I would now like to introduce to you Christian Shaw, who is in his 13th year of tech support at HiPAC. He has traveled the world to perform HiPAC, HiSweep, and DREDGEPACK integrations and trainings. He brings extraordinary experience and expertise to our company, and we are so happy to have him here today to talk with us more about this software. With that, I am going to turn over the presentation to Mr. Christian Shaw.
Hi everybody, Christian here. Glad everybody could join. We're going to be talking about DREDGEPACK today. We've been working diligently over the past year to add some nice features to our package that will allow the dredge operator management to better manage their dredge project. There are common types of dredges that we typically see here at HiPAC, and I'm going to be going through the common ones here and the updates that we have to DREDGEPACK. Most common dredge types that we see are cutter suction dredges, and they can include fixed ladder dredges, swinging ladder dredges. We also can interface into excavators with conventional bucket configurations, clamshell dredging, which is bucket dredges, hopper dredges, water injection dredges, and any type of barge-based vertical pumps. Okay. We cover all types of special dredges. I've included a couple of pictures here the users can see. We'll start up at the top left. Top left, we have an excavator with a pump on the end instead of a bucket. This configuration is quite unique because it kind of changes the dynamics on how we have to handle the installation of the equipment. There's inclinometers on the boomstick and pump that you see with the cutter head attachment. And there's a special power pack at the back. You can see here that perhaps mounting the GPS antennas would be a little bit difficult, so we had to raise those up a little bit. One on the top right, that's a roar dredge. That is a double bucket dredge, and it's a processing plant also included on it. We can monitor the buckets up and down, control and see their position and their depth. And down at the bottom left, we have a Corps of Engineer dredge wheeler. 3-arm hopper dredge, mostly works down the Mississippi River. So we have a lot of different options in what we can install DREDGEPACK on. So if you think your dredge is a special type of situation, I think we have a solution for that. We have basic equipment requirements. Typically, these requirements are positioning devices such as RTK GPS. RTK GPS is easily installed on these machines. Gives you better position than differential. You can bring in the corrections from a VRS network or a base station, and these work quite well. Also need a heading device. The heading can come from a GPS system or it can be a gyro system, an old school gyro system. 95% of the time we see heading coming directly from GPS. So you can typically get one GPS that serves for RTK GPS and heading. And then we have our depth devices. We can compute depth based on an angle. Rotational encoder, say on a crane, we can put a rotational encoder on a drum to measure the up and down of the winch and the wire on the drum of the winch to measure the payout. We also can interface pressure sensors directly into HiPAC. These can be analog to digital sensors, or they can just be digital sensors. bubbler sensors that calculate depth for hopper dredges, string encoders, and if you want a drafted device, we can interface to different types of draft devices as well. These are the basic requirements for dredging: position, heading, and depth. So first we'll start talking about the cutter suction dredges. And these are the windows that we typically see when DREDGEPACK is running and the operator can see what he's moving through and painting the matrix. In the main map window, he's moving through the matrix and coloring by depth. Just to the right of the map window, we see the cross-section profile. The way this one is set up is it's a perpendicular profile out in front of the cutter head. So we show the template with any over depth and the cutter tool relative to that template. This is really helpful for the operator just to control his depth so that he meets the design of the project throughout the template. And then just below that cross section is a cut fill bar. That cut fill bar tells you how far the cutter tool is from the template. So in this case, they're down 3.3 feet below the template. And on the right, we have a data display. There are hundreds of things that we can add to the data display, and it can be customized. All these windows can be customized to fit the operator's use. So what kind of drivers do we use for cutter suction dredges? Well, the most common one is the inclinometer DLL. This inclinometer DLL can handle all types of settings and instruments. The instrument type drop-down, you can choose from 7 or 8 different types of devices. Depending on if you've mounted the angle sensor on the right or the left-hand side of the ladder, you can invert the angle. So if you see in your test that when the ladder's going down, but graphically it's coming up, you can invert the angle. The sensor ID just below that is to accommodate the SEI bus system. US digital sensors are what we commonly see out in the field. These sensors can be on any ID. And instead of changing the ID in the SEI software, you can just identify it here. Inclinometer DLL can also serve as a roll, pitch, draft, or a crane boom mode. So this driver kind of does everything. You can have multiple instances of this driver if you wish. So if you want to use it for angle of the ladder and to bring in pitch and roll, you can add other instances of it to read those values, and they're set for your corrections. Okay. On the right-hand side picture, this is where you plug in how long your ladder is. Because we use the length of the ladder and the angle, that's how we compute the depth and the position of the cutter tool. This is the basic inclinometer window, so you can do your QC check on the dredge. Everybody wants to QC their depth. You don't want to just take the word of the data display for your depth. You actually want to look at this window and make sure everything makes sense. You know how long your ladder is, and when you go down, it gets closer to the trunnion pin or the boom pin. So this graphically shows you that when depth increases, ladder length decreases. So you can see on the right-hand side, the 73.5, based on a 75-foot ladder at a depth of 14.8 feet, is how long the ladder is when it's at depth. This window also serves as the calibration point. Typically, people will calibrate their ladder to the water surface. They'll put the ladder at the water surface, and they'll calibrate the ladder here with this calibration button, radio button in the top left. Now, one of the new features that we have here for cutter suction. We now do 3D cutter suction dredging. Programmer here, Ken Aiken, has made a really neat real-time cloud window. We can display the cutter suction dredge and its cutter tool relative to the pre-survey and show the as dredge depth relative to the template, so that the operator can control his depth and not go below the template and can clean out the channel according to the contract. These shapes here for now are default. In the future, we're going to be able to bring in 3ds files from SolidWorks, and we're moving in that direction. Uh, for crane dredges, slightly different than cutter suction dredges in the way that we compute depth. The windows are very similar. We have the map window here on the left-hand side, and the right-hand side, we show a profile window showing the boom angle and the final elevation. The depth is calculated based on a rotational encoder on the drum. The calibration for crane systems can be found in that same profile window for cranes. There's a calibrate button down at the left. And when you put the bucket at the water level, we can zero out the depth of the bucket. Also in that window, on the right-hand side, you can see that we have a cut fill bar that shows the bucket and its relativity to the template. So it's a good way for the operator to control his depth so that he cleans the channel to the neat line of the template. We've got some new crane hardware here at HYPACK, and it's the HYPACK crane system. This system consists of the rotational encoder for the drum, as you can see on the left-hand side. We've got a nice rim on it, and it holds tight to the drum, and it's calculating depth based on a ratio of the turn of the drum and the turn of the smaller wheel encoder. Okay. Special considerations for mounting need to be made so that the tension is nice and tight on the wheel, but not too tight to kind of ruin the sensor or damage it in any way. This was a perfect example here of being able to get on a dredge and the engineers on the dredge being able to fabricate something really nice and be able to adjust that encoder to go against the wheel of the drum. That sensor plugs into our HYPACK crane box that can be mounted anywhere on the dredge. This box brings in the boom angle indication, the rotational encoder. It's got a HYPACK PC installed in it. It's the HYPACK computer, and any other type of connections that we may have, we can bring right into the box at the bottom. Okay. This one here is installed in the cab of a crane in New Jersey. We found a nice little spot for it. We just threw up a nice piece of plywood and they bolted it on. It looks quite nice. It's not very heavy. It's not very obtrusive and gives us our position and depth of the bucket. The standard driver for cranes is a DQM mechanical driver. This driver does a lot of stuff. One thing that it does that I'll talk about here is you can simulate a crane system. So the system type up at the top left and that drop down can choose what type of system that you have installed, or you can simply just choose simulation. So you don't need to truly have all of these things installed on the dredge to be able to simulate what a crane does in DREDGEPACK. Just below it, we have the bucket mark switch. You specify what serial port that switch is on, and when the operator presses that switch, it makes a bucket mark on the screen so he can track his progress of the buckets. This is nice. Not only are we updating the matrix, but we're also leaving bucket prints on the screen. These bucket files are really important for the managers. It shows when the buckets went down, where they went down, and the depth that they went down at. And these bucket files can be brought through a couple of different reporting programs in HYPACK at the end of the dredging session. Down below that, we have all of our offsets, standard offsets. We have to measure these in the field and input these so that we're accurate in our system. Down below, I show HYPACK Crane System V2. That's what HCS stands for. Here, we use US digital inclinometers and encoders to measure the inclination of the boom and the rotational count of the drum. Here you specify the address for the boom angle indicator. and the holder cable. Now, we may be asking, what's the closing cable? Well, we can measure the bucket opening and closing. So if you want to get real fancy, you can show the bucket opening and closing through the matrix to show the update when the clam is opening and closing. We now draw 3D cranes. This is just an expansion of what we've done with cutter sections and in excavators. But here you can see that we have a crane body and the boom and the bucket. If you have a bucket open and close, we can show three-dimensionally that bucket open and closing. In this picture here, areas below the channel are easily identified by the operator. So you can see the arrow. These areas here have been cleaned and maybe cleaned below the template. But it gives the operator a really good idea of what's going on relative to that pre-survey. We're going to talk about excavators next. The driver for excavators is the Excavator DLL. It's been around for years on end, and we just keep getting better with it. The setup form are similar to the inclinometer and the DQM mechanical driver. You have to specify what kind of type of sensor you have. In this instance, there's a T7 sensor, and we're using the SCI interface that uses the bus system that runs in the background to read the angle of the sensor. It's a real robust system because you can run the SCI Explorer program at the same time you can run DREDGEPACK. In this general settings form for the Excavator DLL, this is where you put in the measurements. Boom stick. If there's a secondary stick, if you put a value in the secondary stick, it realizes that you have an add a stick. If you don't have an additional stick, you leave it at 0 and the program knows that you don't have that secondary stick. Specify the bucket length, the body length, and the bucket width. You set the parameters for DREDGEPACK so everything is to scale. Down below, we'll talk about some of the other features. The sensor override values. If you have a sensor that maybe has gone out, it's gotten damaged, you can force an angle in by checking one of those boxes and typing in the angle. That way you can keep working until you get a replacement in place. Just below that, we have the bucket matrix angles. What this does, it only updates the matrix in between user specified angles. This facilitates not updating the matrix when you're doing something, say, as moving the dredge with the arm of an excavator. So if you don't have a tugboat behind the barge to move the excavator around, like so many do not, and you want to use the excavator arm to claw ahead, this feature is nice. It won't scar the matrix when you're doing so. It's only going to update the matrix in between those specified angles. Takes a little bit of trial and error, but it works great. Just below that, we can use an alternate heading device. We see more and more of these special type excavator systems. Amphibex makes one, and these excavators are mounted on pontoons, and they swing like a swinging ladder dredge. In this instance, we have to take heading from another source. Well, the driver now can facilitate that. We can take heading from an HD25A that's on a mobile. You just use the drop-down box and specify that heading device location. This is a window here showing the 3D cloud for DREDGEPACK for excavators. We're hoping to do 3DS files here in the near future. And when we can do that, it's going to open up the possibilities for a lot of different customized shapes into the real-time cloud window. On the left-hand side, it's showing the real-time cloud. Top right, we've got the map window. In the bottom right, we have the excavator interface profile window. You might need some extra real estate on your monitor. There's a lot of windows that we can use for quality control for your digging operation. And we really like the real-time cloud. Another great improvement that we have here in DREDGEPACK is the DREDGEPACK simulation. I talked a little bit about how the different drivers have a simulation mode. Now what we have is in that HYPACK Excavator Simulator EXE. If you have a Windows 10 computer and you buy one of these Xbox controllers. It's a plug-and-play system. So with those drivers in the map window and in the profile windows, including the real-time cloud, with the gaming controller, you can now control the following: the boom angle, the stick angle, the bucket angle, any open and close of the bucket, the tide, pitch and roll, increase or decreasing the draft, heading, and forward and backward motion of the vessel. The screen here on the right-hand side below the Xbox controller shows you all the key information, shows your positioning and all the values that you've used and changed with the controller. The custom shapes bucket, the bucket shape editor. This is a neat program. More and more we're getting calls to make shapes for these special type attachments for cranes, excavators, cutter suctions. And before, with just the boat shape editor, it was a tedious process to get these shapes made. With this program, we can take a side picture of that cutter tool, open it up with the bucket shape editor, use the cursor to trace on the outline of the shape, identify the pins that attach the body of the machine or the stick of the excavator, and it simply saves this shape out as an SHP file for DREDGEPACK. Typically, these shapes are used in the profile windows for excavators and cranes, but you can use this to make just about any shape you'd like. So have a play with it. It's a nice feature. You can find this in the root HiPack folder, the bucket shape editor exe, and the only caveat is it needs to be a bitmap. So if you try to load a JPEG in there, it'll load just fine. You can see the JPEG. However, it's going to prompt you to load a bitmap. Here's an example of a custom shape from the bucket shape editor. An opportunity to go out to California and work with CS constructors. And they had this special tool. It's a shear. They use this shear at the end of an excavator. They're doing piling removal. They're going to go to each piling, and just below the mud line, they're going to snip the piling off, and that piling will be removed. So we took a side picture of this shear. We traced it out. Now you can see it made a beautiful shape here that we saved out that we can load in the boat shape editor. And you notice that tracking point down there on the bottom left-hand side in the boat shape editor. That's at the point of which they want to measure depth and position. That tracking point's really important. Not only that is those anchor points that identify the connection pin to the stick. So getting the tracking point and the bucket pin requires a little bit, but it's fairly easy, and it saves a lot of time making these custom shapes. Bitmap boat shapes in DREDGEPACK. This is for the map window in DREDGEPACK. Typically, people will load SHP files that they make in the boat shape editor. You can make them detailed, but if you have a bitmap, it's a little easier to display more details. Um, this bitmap boat shape right here was a simple one that I mocked up in Paint. And these are for the nice guys over at LS Marine, if you're listening. So what needs to be done for these shapes to draw and display properly in DREDGEPACK, it's very quite simple. You're going to start off with that bitmap file that you save out of the Paint program. What needs to come along with it is a text document. So you're going to have the bitmap and the text document in the same folder. Usually we keep those files in the boat shapes folder in the root HiPack. The text file is fairly easy. In Paint, you can use the cursor, and in the lower left-hand corner of Paint, it'll show you the pixel X and Y. So in that text file, the first line, separated by a space, is going to be the pixel X and Y. The second line is going to be the length of the vessel. This allows the program to see what the length is so it can scale it properly based on your units in DREDGEPACK. Feel free to get um, and explore how this would work. Works really great. When we talk about the first line, the pixel X and Y, what is that? Where does that come from? Well, it comes from the origin point. And on most dredges, I would say 90% of the dredges, the origin point is the boom pin, the trunnion pin. So you'll hover your mouse over the center of the trunnion pin, and that becomes your X and Y. So a bitmap with that text file, they have to have the same name, one .bitmap BMP and the other one text.txt. It'll work great for you. DQM. DQM is required for many federal projects for the Army Corps of Engineers. If you log on to their website, you can see all the DQM active projects, monitors and documents where and when the dredging disposal operations take place, reduces paperwork, creates detailed production reports, improves project management, standardizes data collection reporting, and creates a standard base for dispute resolution and avoidance. Well, why am I talking about this? Well, HYPACK is a part of this. We compile a lot of the information that goes out for the DQM. That DQM computer usually resides on the dredge, and it gets a feed from HYPACK of all of the production values and position and depth and heading information. HYPACK is only responsible for a part of that, but the production team usually gives us all the rest of the production information. And then once you're certified, you go onto the DQM active project list. So let's talk a little bit more about the DQM. Let's talk about DQM on the crane. The DQM mechanical driver reports the load number, the project trip number, the scow trip, volume of the scow, bucket drops, and location of the dump scow relative to the digging platform. The user is going to have to interact a little bit with this driver to set the loads, the barge alignment, and the trips. But all that information gets conveyed over to the DQM computer that's found on board. DQM for the cutters. HYPACK compiles information about the depth and position. Typically, we get production information from an OPC or a PLC. It can be from any source, however. If you just want to give us a serial cable that has all your production information, great. We can have our programmers whip something up quite quickly to read all that information, compile it in our driver, and send it over to the DQM computer so that the Corps of Engineers gets their JSON file. This is showing the DQM cutter. And the one thing to note is up at the top left, we have the delay. So when something happens, an event happens on the dredge, we're going to have to interact with this driver a little bit. This is going to set the work events. These event types here can be followed in the window event type. So when you have a delay, you'll come in and give the reason and any start and ending time. The bottom right has the send button. So when you're done with the event type, you hit the send button, that information goes over to the DQM computer on board. This is an example of a station event. At station 10+00, there was a plugged line. Let's go ahead and send that over to the Corps of Engineers. Okay, more about the DQM cutter. We have some formulas here that were given to us by the Corps of Engineers for specific gravity, density, velocity, pipe diameter, in situ constant, and the math that goes in. We want to be transparent, so we display all this information in the DQM cutter driver. This is what you'll see on the DQM computer aboard the dredge. Usually it's a standalone computer, and it runs this software exclusively. So to make sure that all the data is being received from HYPACK, you'll go over to this PC, and through the serial, the network interface, you'll make sure that it's being populated with all the pertinent information. It'll also show you at the very bottom when the last bit of information was sent out to the core. It's hard to have a good internet connection out on the dredge, so you want to try to monitor this to make sure they get all the information they want. Okay, so let's keep talking about some other new cool tools that we have to facilitate the dredging process. One of my favorite programs is the Advanced Channel Design program. One of the neat things about a channel design, a CHN file in HYPACK, is that you can break everything down into zones. Not only are zones helpful during digging where you can see by color what zone you're in, but you can also use this in the volumes program, in the 10 model volumes program, to break out the volumes by zone. It's really helpful when you're looking at the report to see where the material resides. Is it in the right slope, the left slope, or the center of the channel? As channel designs get more complicated, zones and identifying zones got more complicated as well. If you have a lot of faces, there was a lot of clicks of the mouse. Now what we have in the Advanced Channel Design program is the ability to use the cursor to identify and group zones together. So in the Advanced Channel Design program, you have a blue pin with an X. It's up by the default arrow in the zoom extent. When using this, you can make polygons around the faces, or you can strike through the faces, and it will group those faces that it bisects into each zone. So it's really helpful. A good example of using this would be if you have an XYZ file and you run that XYZ file through 10 model, a lot of people don't know you can save out a CHN out of 10 model. It can be used in DREDGEPACK. Well, to make zones out of those small little faces, this is a neat tool to make zones out of all those little faces so that when you go run volumes, you don't have volume versus face. Now you have volumes versus zone. So give it a try. And HYPACK 2019 should be available for you. Another neat thing that we've done is we've made the shell 3D. We're always checking to make sure that we've gotten down to grade in DREDGEPACK and in HYPACK. It's really the most important thing, really. Did we clear the channel? So here in the map window, the HYPACK shell, I'm showing three different things. I'm showing a matrix. This was a matrix that was collected from a multi-beam system, and it's being draped over a CHN with zones and a line file. What you can notice here, we're doing three things in 3 dimensions. We're showing the CHN 3D, the line file in 3D, and then the survey surface. This is a good way just to check, quick check, things above grade. Is there any shoal cleanup that I have to do? Or how much left do we have to dig? So it's a good way to monitor dredge cuts. Dredge data playback. HYPACK 2019, you can find this under the view menu in the shell. What this does, it allows you to open up a raw file or a log file and play back what the dredge recorded right in the main HYPACK shell. This utility gives you the ability to back up, go forward, pause or stop, simulation playback. It also allows you to load boat shapes in. Each mobile that you have set up in HYPACK hardware can be assigned a different boat shape. So in this interface, it's quite nice for the people back at the office to take the raw files off of the dredge and be able to play them back in their HYPACK software package in the office. You can kind of get a good idea of what the dredge did and what kind of coverage they made for the day. So give it a try. It's available in the HYPACK 2019 Q2 release.
Thank you, Christian. That was a great presentation, and we hope this gave everyone a better understanding on how our DREDGEPACK software works and can better help your projects. Now, there were a lot of questions that came in, so let's go ahead and start the Q&A section of the webinar. We hope that you stick around for this section, but if you are unable to, we want to thank you for joining us today, and we hope to connect with you in the near future about DREDGEPACK. We're going to try and answer all of the questions, but if yours does go unanswered, we will follow up with you via email over the next few days.
Okay, the first question we have here, what dredge data should I back up onto our server on a daily basis? Well, I really wish people would do more and more of this. It's a great idea to back things up. I would back up the whole project if I could, but I know they can get a little bit big. Maybe you don't need to back up the same TIFF or the same DXF file every day, but there are a few key files that I think you should back up. I'd like to see you back up the matrix file, the file that you're painting. I'd like to see you back up the raw files. So when you see in DredgePack that you're logging, those are the files that I'd like to see you back up as well. And then any configuration file. The Survey 32 INI found in your root project is the configuration file for your hardware. In case something happened to your computer, you can simply put in place a new computer, load that Survey 32 INI into hardware, and get back up and running again. How often should I be making up a project? Okay, well, you don't want to have too many projects, I guess. If you're going to be digging in the same spot for a year, um, maybe you can use the same project for that whole year. Maybe make a new project every year. If you're going from project to project and your dredge is somewhere new every month, maybe each new location make a new project. What type of design templates should we use in DredgePack and where do we load them? Okay, great question. Well, I guess it kind of depends. If it's a more simple type of template, I would make it an advanced channel design. I'd, make my nodes, faces, and any zones. And I would load that in DredgePack under chart channel. You'd load the CHN there. If the template is very complex, and we see that more and more, you can load a matrix file as a template there under chart channel. Just make sure under chart channel, you change the file of type from CHN, what it expects by default, to MTX file. Matrix files can be 20, 30, 50 megabytes in size and be very complicated in its surface and draw just great as a template in DredgePack. So that's the kind of design template I'd like to see. CHNs or matrix files loaded under chart channel. How can I get more information on the rotational encoder? Okay, well, you can contact us directly, and I'd be happy to help. We use the US Digital HD25A encoder, and I can definitely tell you how that is interfaced into our hardware program. So yeah, I'll be happy to help. US Digital HD25A. Is there some simulation tool for the bubbler driver? Great question. I don't have an answer for that, but I can get you the answer. So let's get this person's name and I'll follow back up with them. Okay, how accurate will my excavator bucket be with RTK GPS? Well, I guess that kind of depends how accurately you measured all the offsets. I guess that's a good place to start. So typically we see excavators measured out with their offsets with the total station. So if you can get somebody in there with a reflectorless total station and measure all the offsets and the GPS relative to the boom pin, and then the vertical component from the RTK GPS antenna down to the boom pin, that really tightens up things nice. But you're only going to be as accurate as your least accurate instrument. So I guess it depends. How accurate my excavator will be. I'll give you an example. I just got off a really neat project out in Oregon, and we were less than 2/10 at the bucket teeth at benchmarks that we set. So that was really nice. So it's based on how accurate you do your measurements. and the kind of RTK fix quality you have. How do I restore lost information that I dug through in a matrix? Okay, um, the matrix is being backed up at the time interval that you specify in DREDGEPACK. So under options and navigation parameters, you set the matrix backup time. I wouldn't recommend doing it every minute. Your archive folder is going to get really big. Um, but that's where you're going to find those MXB files. So those MXB files that are in the archive folder in your project can be recovered and restored back to a matrix. You go to the HYPACK shell, you right click on the parent matrix files, and then there's an option, convert MXB to MTX, and that'll restore you back if you lost anything. How do I install the inclinometer position on crane arm? So I think they're talking about the boom, and typically that inclinometer on a crane boom can go anywhere. An angle is an angle, and we can calibrate that angle no matter what the set orientation is on installation. You can put it upside down. It just needs to be along the flat edge of the boom arm, and then we can calibrate that right in the HYPACK DREDGEPACK software.
Okay, everyone, we are unfortunately out of time, so we are going to wrap it up. We want to thank you for all of your participation and hope you enjoyed the webinar today. Everyone will get a copy of this presentation, and we will get in touch with anyone who had unanswered questions over the next week. Also, please don't hesitate to contact us. We want to hear from you. We can be reached at sales@hypack.com. And don't forget to check us out on Facebook, Twitter, LinkedIn for upcoming news and updates. We hope to talk to you all soon and have a great rest of the day.